So here's a funny situation to find ourselves in. We've got this vector. I know it's a vector. I see the arrow. I know what direction it's going. It's going 41 degrees below the x-axis, like a 41-degree angle of depression. And I know how hard it's pulling. It's pulling with 25 newtons of force. What I want to do is I want to know the components. Now, till now, that was easy. I just counted squares. How many units to the left, right, how many units up, down. I was done. But what do I do if there's no grid? What do I do if I only have numbers? Well, it turns out to be not too tricky because we already have the skills we need. Just notice that if I go right here to the very tip of the vector and I draw a segment perpendicular to the x-axis, I get a right triangle. And now I can think of that 25 newtons as being the radius, and I can think of this side of the right triangle as being x, and this side of the right triangle being y, and that x piece plus that y piece makes the vector. Now once I've got that, then it's pretty easy to work backward to find x and y. I just have to remember my formulas. I know the radius. I'm looking for x. Let's see, which trig function uses the radius and uses x? Cosine. So I would write cosine of theta equals x over r. And then what I really want to do is find x. I know what r is already. I know what theta is already. X is my unknown. So I'm going to multiply both sides by the radius in order to get x by itself. And so now I have that the radius times the cosine of the angle gives me side x. And then I can just fill in the blanks. The radius is 25 newtons times the cosine of the angle, which is negative 41 degrees. Mr. Nunn, why are you saying negative? Well, look at the direction. Starting from here, which is where angles start from, I'm going this way. That's clockwise. That's got to be negative. So negative 41 degrees, that's going to give me x. 25 newtons times negative 41 degrees. So now I go over here, and I grab my calculator. Check my mode, always check my mode. I'm working in degrees this time, so I'm making sure that I'm in degrees. I have 25 newtons times the cosine of negative 41 degrees gives me 18.87 newtons. Now this problem only has two significant figures, so I'm going to round that to 19 newtons. 19 newtons is x. So there's my x component, 19 newtons. What about the y component? Well, I'm going to do the same idea. I know what the radius is. I know what the angle is. I want to find y. That means I want to use sine. So sine of theta is y over r. Now just like before, I want to get y by itself, so I'm going to multiply both sides by r. Cancel out there. And so I have r times the sine of theta equals y. And now I just fill in the blanks. The radius is 25 newtons. The sine times the sine of negative 41 degrees, angle still negative because of the direction, gives me y. And so now I go to the calculator. 25 sine negative 41 gives me negative 16.4. And again, I have to round to two significant figures. So that gives me negative 16 newtons for y. The y component is negative 16 newtons. So now we know that our force is pushing 19 newtons to the right and 16 newtons down. Notice the negative indicating down. Now, that's pretty much all there is to it, but every now and then the picture can be sneaky. Let me show you what I mean about a sneaky picture. Might as well hold on to those two formulas. We're going to be needing those in a minute. Let's suppose you were shown a picture like this. You got a 53-degree angle on a 17-pound force, and you need to find the components. Well, you might be very tempted to just go, okay, I know cosine, r cosine theta, the radius is 17 pounds, times the cosine of 53 degrees. And if you wrote that in, you'd be in trouble, because that angle's not really 53 degrees, because in proper form, angles are always measured from here. This is where 0 is. So I need to correct that. They're only showing me this little bit of angle, when what I really need is all of this angle. So let's think about that. From here to here is 90. From here to here is 90. That's a total of 180. From here to here is 53. So I got 180 plus another 53 gives me 233 degrees. And that's the angle I need to put right here. 233 degrees. And then I go to my calculator. I have 17 cosine 233 gives me 10.23. And this problem only has two significant figures, so I'm going to round that to 10. 10 pounds for the x component. What about the y component? Well, same idea. 17 pounds multiplied by the sine of 233 degrees is going to give me y. 17 sine 233 gives me negative 13.58, which rounds to negative 14. Negative 14 pounds is the y component. Negative 14 pounds. So as long as you're careful about keeping an eye on your angles, the rest of this is really pretty darn easy. It's just radius times the cosine of the angle to give you the x component. It's radius times the sine of the angle to give you the y component. And that's all there is.